Hello student, welcome and very good morning to you. Today I will be discussing ERODOV numerical 9, 10, 11, 12. In my previous two videos, I have already discussed question number 1 to 8. This discussion will be extremely helpful for you for the preparation of JEE Main and JEE Advanced. Now let's start. Question number 9. A boat moves relative to water with a velocity which is n equal to 2 times less than the river flow velocity. If velocity of the boat be v and velocity of the stream u, okay, then here u by v this equal to this is the 2. Okay, no problem. At what angle to the stream At what angle to the stream direction must the boat move to minimize the drifting? Okay, suppose this is the river. It flows from this direction to this direction. Okay, suppose velocity of the swimmer directed along this direction. So, angle made by the velocity of the swimmer with the direction of the stream, this is the theta. So, component of velocity in the direction of the stream, this is the u, this is the v cos theta, and normal and in normal direction the velocity is this is the v sin theta. Okay, no problem. So only this component help to cross the river. If d be the width of the river, then time to cross, this is the d by v sin theta. No problem. Now, velocity of the swimmer now resulted velocity of the swimmer in the direction of the stream. This is the u plus v cos theta. No problem. Therefore, drift x equal to, look at this. This is the u plus v cos theta into this is the d by v sin theta. No problem. Therefore, this is the d into this is the u plus v cos theta divided by this is the v sin theta. Now look at this. This x becomes minimum if dx by d theta is equal to 0. Now look at this. This is the d theta of, look at this. This is the d into this is the u plus v cos theta divided by this is the v sin theta, this equal to 0. Okay, no problem. Therefore, look at this. Look at this. This is the sin square theta. Okay, no problem. Into this is the sin theta into d theta of this is the u plus v cos theta. No problem. Minus, look at this. This is the u plus v cos theta into d theta of, look at this, d theta of this is the sin theta. This equal to 0. Here sin theta into, look at this, this is the 0 plus this is the v into minus sin theta. No problem. Okay, minus u plus v cos theta into this is the cos theta. This equal to 0. So look at this. This is the minus v sin square theta minus this is the u cos theta minus v. Look at this. This is the cos square theta. This equal to 0. Therefore, look at this here minus v. This is the sin square theta plus cos square theta. This equal to this is the u cos theta. No problem. Therefore, u cos theta this equal to minus v. Therefore, cos theta equal to this is the minus V by U. Look at this here, U by V is equal to 2. Therefore, minus V by U equal to this is the minus half. Therefore, theta equal to this is the 1 to. So, to minimize the drifting, the angle of steering of the boat with the stream should be 120 degree. Okay, next. Now, question number 10. Two bodies were thrown simultaneously from the same point, one straight up and other at an angle of other at an angle of 60 degree with the horizontal. The initial velocity of each body equal to this is the 25 meter per second. Neglecting the air drag, the find the distance between the two bodies at t equal to 1.5 second later. Look at this. Suppose this is the horizontal direction. Along this direction, unit vector I cap, and in vertical direction, this is the unit vector j cap. No problem. Now look at this. One body thrown vertically upward. Okay, and another body thrown at an angle of, look at this is the 60 degree with the horizontal, no problem. Both have velocity, this is the 25 meter per second. Now look at this angle is equal to 60 degree. So component of this 25 in the horizontal direction, this is the 25 cos 60 degree. And in vertical direction, look at this. In vertical direction, this is the 25 sine 60 degree. Okay. And 25 is the velocity of the first body. No problem. So look at this. The velocity of the first body V1, this equal to 25 j cap. And velocity of the second body V2 equal to, look at this. This is the 25 cos 60 degree I cap, plus this is the 25 cos, this is the, look at this, 25 sine, this is the 60 degree j cap. Therefore, a relative velocity of 1 with respect to 2, this is the v1 vector minus this is the v2 vector. No problem. So v1 is equal to this is the 25 j cap, and v2 equal to, look at this is the 25 cos 60 degree. So this is the 12.5 I cap minus, look at this is the 25 sine 60 degree. So this is the minus 25 into root 3 by 2 into j cap. Okay. So look at this is the 25 and this is the minus 12.5. And now look at this. Now this minus this. Okay. So here this is the minus 12.5 I cap, and this is the 25 j cap minus, look at this is the 25 into 0.866. Now look at this 25 into 0.866. Look at this, it roughly taken as, look at this, it roughly taken as zero point 0.9. So 25 into 0.9, that is 22.5. It is taken as 22. Therefore, this is the plus 25 j cap minus this is the 22 j cap. Okay. So look at this is the minus 12.5 I cap plus this is the 3 j cap. Therefore, modulus of V12 vector, this equal to, this is the root under of, look at this is the minus 12.5, this is the whole square plus this is the 3 square. So look at this is the almost 150 and this is the 9. So this is the 159. So it is almost equal to, this is the 30. Okay, meter per second. So distance between the two particle after the time 1.7 second, this is the d equal to, this is the V12 mod into this is the 1.7. So look at this is the 13 into 1.7. Okay. Look at this 1 into 13 mean into 13. Now 13 into 0.7, almost 9. So look at this. This is almost 22 kilometer. Okay, understood? Now question number 11. Two particles move in a uniform gravitational field with an acceleration g. At the initial moment of the particle were located at one point and moved with velocity v1 equal to, this is the 3 meter per second, and v2 equal to 4 meter per second horizontally in opposite direction. Find the distance between the two particles at the instant when their velocity vector becomes perpendicular, becomes mutually perpendicular. Okay. Now look at this. Suppose this is the point of projection. Okay. One has velocity. This is the 3 meter per second along this direction, and other has velocity. This is the 4 meter per second along this direction. Suppose look at this. This is the I cap, and this direction is the j cap. Therefore, final velocity of the first vector after the time v1, this equal to, this is the 3 I cap plus this is the minus g into t j cap. No problem. And final velocity of the second vector and final velocity of the second particle, this equal to v2 equal to, this is the minus 4 I cap. Look at this, because 4 is the opposite to the direction of I cap. Minus, look at this is the gt j cap. Look at this, from condition v1 and v2 vector are perpendicular to each other. Okay, when they are perpendicular to each other, we have to calculate distance between them. That is, look at this, the trajectory, and look at this. Okay, okay, and this direction. So their velocity vector are perpendicular to each other. Look at this here, velocity vector directed, this is the v1 vector. And here velocity vector, this is the v2 vector. Now, angle between v1 vector and v2 vector, this is the 90 degree. Look at this. This angle is 90 degree. So we have to calculate distance between these two. So we have to calculate distance between these two. Now, distance between these two, this becomes, this is the relative velocity. Now, v1 vector minus v2 vector. So, v1 vector minus v2 vector into t with a distance between the two particles when angle between them is 90 degree. Now, we have to calculate time t when v1 vector and v2 vector are perpendicular to each other. As v1 vector and v2 vector are perpendicular to each other, so v1 vector dot v2 vector, this equal to 0. Now v1 vector is equal to 3 I cap minus, this is the gt, this is the j cap, dot, this is the minus 4 I cap minus gt j cap, this equal to 0. So look at this is the I dot I, what? So look at this, minus 3 into 4 plus this is the g square t square, this equal to 0. Therefore, t equal to, this is the 12 by g square under root. So look at this is the 1 by g into root under 12. No problem. Now look at this, the distance between them d equal to, now look at this, distance between them d equal to, this is the v1 vector minus v2 vector into time. Time is equal to, this is the root under 12 by g. So look at this, v1 vector minus v2 vector. So look at this is the 3 I cap minus 4 j cap. So look at this is the 12, this is the 12 I cap, no problem, into time. Time is the 1 by g into, this is the 12. So look at this here, 12 by, this is the 10 into root under 12 into I cap. Okay. So look at this here. This is the 1.2 and root over 12 means this is the 3.5. And root over 12 is equal to almost 3.5. So look at this, 1.5 into, this is the 3.5 I cap. Look at this, 0.2 into 3.5 means 0.7. So this is the 3.5 plus zero point 0.7. So 4.2 is the distance between the two particles. Okay, understood? Now look at this question number 12. 3 points are located at the vertices of an equilateral triangle whose side equal to A. They start moving simultaneously with velocity v constant in modulus, with the first point heading continually for the second and second for the third and the third to the first. How soon will the point converge? Now look at this. This is the position of the first particle. This is the position of the second particle. This is the position of the third particle. Now look at this. 1 heading towards 2, 2 heading towards 3, 3 heading towards 1. Now for a very small instant, look at this. 2 moves from now. Now for a very small time interval, 1 moving towards this point. So look at this direction of motion 3 along this direction. Okay. In the same way, in the same time, 2 moves along this direction. So direction of motion of 1 direct this direction. And in the same time, 2 directed along this direction. So look at this. At any instant, they are always the vertices of an equilateral triangle of decreasing side and finally converges at the centroid. So distance of centroid from the each vertex of equilateral triangle, this is the d equal to, this is the root 3 by 2, this is the height into, this is the 2/3, because the distance of centroid from a vertex is equal to 2/3 times the height of the equilateral triangle. So look at this is the height and this is the 2/3 times of height. So look at this is the a by root 3, no problem. Now look at this, the direction of velocity of 2 along this direction is v and this angle is 30 degree. So component of velocity towards the centroid, this is the v cos 30 degree, no problem. Therefore, time to reach the centroid t equal to distance a by root 3 divided by, this is the v cos 30 degree. No problem. So look at this. This is the a by root 3 divided by this the v into root 3 by 2. Therefore, this is the 2a by, this is the root 3 into root 3, that is the 3v, is the time to meet at the centroid. Okay, understood. Many thanks for watching this video. This video will be extremely helpful for your preparation in JEE Advanced, JEE Main and other competitive examination. Okay, thank you.